So welcome to the walkthrough for the Edexcel higher paper. It's the GCSE. It's the summer of 2018 paper, as you can see there. And we are on the 2R paper. So let's go. Formula page, but let's crack on with the rather strange number 1, because it's only worth 2 marks, and it turns out to be simple, but still simultaneous equations. So we're told they're in order. So x is smaller than y, so do make sure you get the answer the right way around. The mean of 3 numbers, so when we add them all up, if the mean is 11, their total would be 33. So let's just rejig this. I'll put the y at the front for reasons which will become apparent in a sec. So y plus x equals 23. Then we're told the range. Now, range is biggest take away smallest, and you've been told that y is the biggest integer. So it needs to be y take away x. They have a difference of 7. And so there you go. You've got your simultaneous equations. Your choice. I'm going to get rid of the x's. They're different signs, so we add them. So 2y's are 30. That spits out sort of worth 2 marks. Don't do too much work. Y is 15. And because they add together to make 23, x is 8. Don't need to put too much effort into that last stage. Number 2 is all about they've given you the pressure, force, area, but you actually need to just rejig that slightly so that force equals pressure times area. And as you can see from that there, you've got the length and width of the rectangle. They need to be multiplied. They give you 2.5 for the area, and your pressure is 42. Get them multiplied. What am I doing? Get them multiplied for 105. On we go. So we're making candles. Who cares? It's all about the numbers, really. So 6.3 kilograms, and then we're going to grams. So it's your choice whether you work in grams or you work in kilograms. I always prefer to avoid decimals where possible. So I go for bigger numbers. In other words, I transfer it into grams. So each one uses 210 grams. So when we divide the 6,300 by 210, we know we make 30 candles. 2/5. So 2/5 of means times, and they are $13 each, so times by 13. That makes us $156. So the other 3/5 of 30 are sold at a 20% reduction. Well, if you want to reduce $13 by 20%, you times it by 80%, or in other words, 0.8. And that gives us, when you've got 18 sold, what we got times 10.4 is $187.20. Now, I suspect this would be a percentage profit question, but it's not. It's much easier. Work out the total. So simply get those two added, and I get 343.20 cents. On we go. So some pretty standard algebra. You know this is coming. So 2 brackets, but they're separate, so there's no c squared or anything. Treat it as 2 separate questions. Bottom one's got 2 brackets, which are adjacent. So you've got 3c, take away 21, and you've got 6c plus 8. Got to be tidied up. There's 9 c's. Negative 21 plus 8 means negative 13. When you're expanding brackets, your choice whether you do loops, do it mentally, do a grid. I don't care. No one cares, as long as you get the right answer. I always do a bit of loops. So the first loop is x squared. The final loop is minus 14. And the x terms, I get 7x, take away 2x, 5x. Part C, it's a factorise, it's got a squared, but there's no constant on the end. So it is a single bracket question. I always say to my students, do numbers first. So 28 and 21 are in the 7 times table. 7 4s are 28. 7 times negative 3 is negative 21. And then we do the y's. They've both got a y in, but it's the first term that's got an extra y in. So when you multiply, you get the y squared. Part D, several ways of doing this. You might split the fraction, but I'd stay away from that. 8 denominators when you're trying to solve, get rid. Level it off, times both sides by 4. All right, I've forgotten the minus 2. We'll put it there. Let's isolate the x's. So there's more x's over here, so I'll take 5x away. So I take 7x away to get 5x. I'll take 4 away from both sides to get negative 6. And now divide by the coefficient of x. So it's minus 6 over 5. Obviously minus 1.2 or minus 1 1/5, all correct. Number 5. So as soon as you see that, you've got 6 hours, 42 minutes. Now, when you have questions like this, you've always got to think, how do I put time into a calculator? It's easy when it's 30 minutes, because that's half an hour. So you put in 0.5. So you've got to be careful when you've got daft number of minutes. But it's not a problem. 6 hours and minutes are 1/60th of an hour. Obviously, you can cancel down 21 over 30. What is that? 7 over 10. All right. But the fact is, the flight time, when we put time into our calculator, we're going to use 6 and 42 over 60. Or in other words, it is 6.7 hours. Probably easier to stick that in your calculator. So anyway, it's a distance, speed, time question. We want distance. They're adjacent, so it's a multiply. So it is 6.7 times 650, 4,355 kilometres. Does that seem a reasonable answer? Always worth checking because they can't give you misleading numbers. 4,000 kilometres does sound like a decent flight. Number 6. So we're investing rupees for the next question. So what we've got to do for number 6, it's going to be a multiply. It's a compound interest. So it's the old capital. You're getting interest, so it's 1 point, and it's 0.15 power of 3. And it wants nearest rupee, so I get 20,913.56, etc. In other words, 20,914. Number 7. So A, good old laws of indices, numbers first, then letters in turn. So 20 over 4 is 20 divided by 4. X squared divided by x squared, so you subtract the powers. I could write x to the naught. I could write times 1. I certainly don't just want to write 1. That would look stupid. Me personally, it's x to the naught. Well, ignore it then. And on the y's, you've got power of 6, power of 2. They must be subtracted. Rearranging, transposition of formula, whatever you're normally calling it, you subtract f from both sides. And to isolate e, you need to divide both sides by 3. Number 8, it's a wordy one, and basically it is hidden Pythagoras. So Stanley walks due east and then due south. So due east, due south, perpendicular, 160, 200. How far is he away? So AC is the hypotenuse, so we need to find AC by taking the 200, the 160, squaring them and adding them, and square rooting our answer. Gives us 256.129, but to 3 sig figs, that's a 256. Number 9. It's one of them that always looks more complicated than it actually is. Note one thing before you even start. They share a side, so sides are equal. So this is isosceles, and that's an x. Now let's worry about internal angles. So don't forget about that formula. To find internal angles, you subtract 2 from the number of sides. That tells you how many triangles fit inside a shape. So for a pentagon it's 3, for an octagon it's 7. It's then multiplied by 180, because that's a triangle. And when it's a regular shape, you divide by the number of sides. So the internal angle of a pentagon, grab your calcs, it's 3 times 180, that's 540, divided by the fact it's got 5 angles, so each of them is 108. We do the same for the octagon. 8 minus 2 is 6, times by 180, all divided by 8. We get a 135. Now this helps because we can now find the angle at B. B is angles around a point. The angle here is 360 minus the 135 that's here, minus the 108 that's there. So I'm getting 117 for the apex angle. And now we've got an isosceles triangle. It's 180. Take away that 117. But because these base angles are equal, you halve your answer. So you end up with a quite strange but correct 31.5 degrees. On we go. So number 10. It's a case of you've got a trapezium, which means they're parallel, which tells you really that the height of this triangle, always worth redrawing it, that's C and that's D. The height of this triangle is 12.5 and the base of the triangle is 24.3 minus the 16, 8.3, and we're after this acute angle at the top. So as always, what sides do we have? We've got the opposite and the adjacent. So to find this angle, I'll call it Y. It's an inverse tan for an angle, and its opposite, 8.3, divided by the adjacent, 12.5, which gives us 33.58, etc. But don't congratulate yourself too much. That's not the final answer, because that's the little bit of the angle. To find the full angle x, got to add on that right angle that we created. So we must add on 90 while also rounding to one decimal place. 123.6. Job's a good one. Number 11, well, this one's the easy bit. So the modal is most common. 36 is the highest frequency, but 36, don't forget, is not your answer. It's the group that's the answer. So it's 100 is less than m, which is less than or equal to 200. Part B, another easy mark. Use your calc, or always worth in your exam. Use a calculator just in case your brain does something daft when you go through past papers. Not that bothered really, are we? But here we go. 10, add on the 36 and keep going. Make sure you end up, because it does say in the top part of the question, 120 families, so it's a nice way of double checking if they've given you that information. You should end up with 120 down there. Add on 20, add on 15, and we add on 5. So on the next page, yes, people, I have cheated. I have already drawn it. I've done it on my worked answers, and I've cut and pasted it across because me and this electronic pen are a rubbish pairing. But don't forget, when you plot your cumulative frequency, it's these numbers you use as your height, and it's the upper class boundaries you use on the x-axis. And you join it up. It says cumulative frequency graph, which means you can do freehand, but if it gets messy, why? Always use a ruler if you've got that option. So part D, to find the interquartile range. So upper quartile and lower quartile. Lower quartile is at your 30th. So you go along to your graph and down. Mine's at just under 150. And your upper quartile, treble the 30, is at 90. So again, go along and down. Looks like bang on 350 to me. And because it's range, that means subtract. So I get 205 for the range. The mark scheme, I'm right at the top of that limit. The mark scheme does allow 175 to 205. So plenty of leeway. As I say, so the perfect answer is more like 190. But hey, who cares? And final part, you can just see it at the bottom. Find the 450, that's there, up to your graph and along. It's kind of 12 or 13 for me, because we want above, don't forget, so that's that bit up there. So I settled on 13 for my answer. Turns out the mark scheme actually says literally 12 or 13. So there we go. Number 12. They always look nasty, but once you see them, they're not that bad. Now, it does say show your working clearly. It doesn't say give reasons, so you don't have to. So either write on your diagram or write down here. It's all good. So I would simply say that angle COA, what you've got going on here, they are radii. They are perpendicular and give you 90 degrees. So if you've spotted it, COAB is just, well, it's a kite really, but it's just a quadrilateral, and the angles inside add up to 360. So you take away the two 90s, that's 180 in total. You take away the 74, and we get the angle in the middle there to be 106. And we want to work out angle A to D to C. Now, if you can see it, I'll go for a different colour. Come on, electronic pen. if you can see here, a lot of teachers will call it the arrowhead inside a circle theorem. If you've got the centre and the angle on the arc, they are double and half each other. The angle at the centre is double the angle on the circumference. So to find ADC, believe it or not, you just halve 106. It's literally it. 53 is your final answer. Next, number 13, they do look gibberish, but even if you hate coordinate geometry, you can always avoid zero on these by simply stating the obvious. And I hope it's obvious, because it is the old y equals mx plus c coming into play. So when you look at L1, the gradient is the number next to x. Bosh. And if that's all you do, well, at least you're picking up a mark, and 1 out of 4, it's all right. Now you're then told it's perpendicular. So L2, when a gradient is perpendicular, it's negative reciprocal. So change the sign, it becomes positive, and 2 becomes a half. You've earned a second mark. All right. So we now need to apply y equals mx plus c, where we've got the gradient m, but we've also got the x and the y, because x equals 4, y equals 7. So I'm going to replace the y with 7. I'm going to replace the m with a half, replace the x with a 4, and there's a c on the end, and we can now use our calc or common sense or whatever. Half times 4 is 2. Subtract that from both sides. We've got that c is 5. I need a bit more room because we haven't finished. We've got the equation y equals a half x plus 5. But let's not forget, when something crosses the x-axis, another name for the x-axis is that y equals 0. So the y value will be 0. Your job is to get on your calc and find the x value. So I will take 5 away from both sides and double both sides. I get negative 10. Bit over the top that one, but good revision question, I think. And again, it's one of them not to leave blank. They come up all the time. State the gradient, state the flip of the gradient, the negative reciprocal. Because on your next exam, it's going to get you a couple of marks, even if you don't finish the question. It's well worth it. Number 14, the key here is look at them all. They are all powers of 2. So use your calc or your fingers. 2 times 2 times 2 times 2. 128 is 2 to the power of 7. 4, I'm going to replace with 2 squared. Leave the power alone. And 2 to the x, no need to tweak that. Laws of indices tells us that a power to a power, they get multiplied. Laws of indices also tells us when you times numbers which are the same base, you add the powers. And we can also say if 2 to a power is equal 2 to a different power, the powers are equal. Job done. Divide both sides by 5 for 7 over 5, or 1.5. And now we get one of the weirder Venn diagrams. I even wrote strange on my work solutions because here's the catch. Those numbers represent numbers of elements. So 7 plus 3 is 10, plus 8 plus 1 is 19, plus 4, 23, 32. So it looks like there are only 6 numbers in this Venn diagram. Wrong. All right, there are 30 odd. Okay, so let me just check that. 10, 18, 19, 32. So when you put Venn diagram bits together, we need to be adding. All right, that's a weird bit of that. So find the number in A and B together. So that means look at whether you call it a figure of 8, almost like an infinity symbol. They're the digits we want: 7, 3, 8, and 1. Whoopsie doodle. And these need to be added. So 7 plus 3 is 10, plus 8 plus 1, that's 19. Strange, but yeah. So, second part is saying intersection of outside of A. So the digits which are outside of A are there. Intersection, so also we want them, they must also be inside C. And that gives you your answer. It's the 1 and the 4, 5. And finally, the union of outside of A. So let's circle all the ones outside of A. Union, that means together with, outside of B. So there's outside. That's also out. Whoops, that's not. What am I doing? That's also outside of B. And so is that. But here's the crux to this question. You don't count the 4 twice. If you were doing a question where it's more normal, like it's people who take French and people who take German, you wouldn't add elements together, or you wouldn't say 3 plus 7 together. Probably more saline of a thing is where you do you put prime numbers in one. You don't add up those prime numbers and multiples of 4 and whatever. So we simply add the circled numbers, but just because it's circled twice doesn't mean you add them twice. It's 7 plus 8, 15, plus 1 plus 4 plus 9 to get 29. Think about it. If there's only 32 in the set, if you added on the 9 twice, you've got more people in the diagram than are in the diagram. And that's what makes this, that's what you have to think about. But yeah, did think this was a weird question, particularly when it's only for 3 marks. Number 16. So it's all about odds and evens. So as soon as I see it talking about odds and evens, I start thinking, how many? So we've got odd is 5 out of 9 to begin with. Sorry, 5 out of 8. Should have read the question better. And even is 3 out of 8. So Fiona takes 3 counters and adds them to get her total. So how can Fiona get an odd answer? So one way is odd plus odd plus odd, which in fraction form is 5/8, 4/7, and 3/6. All multiplied, but also, so that means and, she could get an even, and an odd. So even would be 3/8, 2/7, and an odd would be 5 out of 6. But hold on, what about even, odd, even, and odd, even, even? Here's the good news. They'd both be exactly the same as the one you've just done, because the numerator would still be 3, 2, and 5, but in a different order, and the bottom numbers would still be 8, 7 and 6, and they'd be in the same order. But whatever order they're in, there's 3 of them, and they're all the same. So that's what you need to stick into your calculator. Take care with your brackets. Do make sure you get 25/56. Number 17, bog standard. Even though you've got a calculator, it's always going to say prove, show, or use algebra. So let x equal your thingy. Odds them up so that the recurring is straight after the decimal point. Now you could go to 100x. Maybe you've been trained to do it that way, and that's fine, but it won't help you because you want the recurring to be exactly the same. So you need to budge them up twice. So you need to times them by 10 twice. And timesing by 10 twice means timesing by 100, which means you should get 1000x. But if you've been trained to go 10, 100,000, absolutely fine. And now we do bottom, take away top. So 990x, 436, take away 4, and the recurrings disappear. And we end up with 432 over 990. And that's it. The examiners are happy because now you stick that in your calc. You've done the algebra bit. Just press your buttons on your calc, or even don't and just jump straight to that, because that's a 2-marker. You've done more than 2 marks worth of work there. That is plenty. Part B. So your choice. Do you want to simplify the surds right now, or do you want to times top and bottom by √3 now? Your choice. I've gone with the simplify to begin with because it keeps the numbers smaller. So on the top, it's √4, √5, and it's √16, √5, all over. And I'll shorten it up because this means 2 √5, this means 4 √5. So in other words, you've got 6 of them. We now need to rationalise. So we times top and bottom by √3. That gives me 6 √15. And on the bottom, √3 times √3 is √9, or in other words, 3. Then the 6 and the 3 cancel, but here's the problem. You haven't yet finished. Notice how the question is phrased. It does not have a number before the bracket. It hasn't got a B √A or something like that. So it wants you to take the 2 inside it. So the way you do that, change the number 2 to √4, because now you can multiply them, because the correct answer, you might think 2 √15 was correct, but the way the question's phrased, it wanted it writing as √60, so that's a pretty sly one in my opinion. Number 18, simultaneous quadratic equations. You could rearrange the second equation to make y equals, but what's the point? That's just extra work for me. As soon as I see this question, I go, stick it in. So there's a 2, and I'm replacing the letter x with 2y minus 3. And now it's you and a battle to expand, simplify, collect like terms, maybe factorise, maybe formula, but find the values of y. So let's go. So there's a 2 in front of it, so I square brackets by squaring the first, so that's 4y squared, but we need to double it. Squaring the last is 9, so double it. And timesing the 2 together is -6y. and I need to double that to make negative 12y, but then it needs doubling, minus 24y. If you don't believe me, do it the long way, but that's how I square brackets. And we've got 3y squared, and we now aim for a 0. So let's collect our y squareds together. There's 11 of them. Our y's are negative 24 and 18. Take away 14 is 4, as in positive. So you could use the AC method, but again, when the coefficient of y squared is a prime number and the final number is small, it's also positive. So these two have to be minuses, otherwise you can't have that. So there's loads of clues there, but at the end of the day, it's 2 and 2. So I have said this on a couple of other videos. Do not, because you'll remember, it doesn't say these are equations of lines on a graph or anything. They don't want you to give your final answer as coordinates. That's a no-no. So at this stage, I like to split my page in two. Do the easy solving first, so y equals 2 and y equals positive 2/11. For obvious reasons, I pick the second equation. So x is equal to 2 lots of y. That's 4. So my first answer, when x equals 1, y equals 2. And when x equals something, y equals 2/11. As I say, avoid the coordinates. So grab your calc for this one because it's harder. So x equals 2 lots of y minus 3. So when you stick all that in your calculator, you get a lovely negative 29/11. Not the friendliest of answers, but it's correct. Number 19. Errors and bounds. Always start these the same way, in my opinion. Don't start reading here until you've earned your marks from here. Write down your 8.4. Make a menu. Go upper and lower bound. That's a rubbish 5. And 8.35, because you go up and down by half the rounding amount. So let's have 6.3. Could be up to 3.5 and down to 2.5. And I'll do it up here. 0.27 could be 275 or 265. Now, when you look at this equation, it wants the upper bound. So in other words, we need to make this the largest we can. So your value of P needs to be as big as possible. Take away the value of Q, so you need to subtract the smallest possible number. And you need to divide it. When you want an answer as big as possible, you need your bottom number, your denominator, to be as small as possible. So that is lower of T. So let's put some numbers in those places. So that's 8.45 minus the lower of Q, that's 6.25, all over the lower bound of T, which is 0.265. Oops, I'll recycle that. And it wants the answer to 1 decimal place. I got 8.3018. In other words, 8.3. They are tough questions, those, and not the most generous when it comes to marks, but, get into that habit upper and lower, take the values you're given, up and down by half the rounding amount, and get on with it. You might end up selecting the wrong number in one of these. So what? You'll still get 2 out of 3. There's much harder questions, in my opinion, than errors and bounds. Number 20. So, as on the question a couple of questions ago, how you factorise it is up to you. The AC method will work a treat, but so will the quadratic formula. And those of you who prefer to do it by sight, don't blame you. If the numbers aren't massive, I prefer to do it by sight as well. But no matter which way you do it, as long as you get 4x plus 3 and x minus 2. So, your critical values, I must hasten to add, not your solutions, your critical values would be 2 and -3/4. And we have a quadratic. It's a positive x squared, so it's that way round. And that's now your key. We are being asked for where is it greater than 0? Where is it above the axis? It's to the right of 2 and to the left of -3/4. Got to be honest, when you think about how much work we've just done for question 19 on bounds, that is a gold mine. Next, I've cheated, but let me explain. So don't forget, when there is a number in front of anything, could be a sin x, could be an x squared, could be anything, you have a scale factor vertically of whatever that number is. So it means using the x-axis as my base, I needed to double the distance away from the x-axis. So the apex here is 3 above. I had to make it 6 above. And these 2 endpoints are 1 below. I needed to make them 2 below. So make that one of your revision things, folks. Not loads of marks, but nice to revise. And same for the next one. Again, the answer's there, but let me explain why. When you have an x and you replace it with a negative x, that is a reflection in the y-axis. So anything to the right needs reflecting to the left, from the right to the left, and in this case, from the left to the right. Now, when it comes to transformations of graphs, big bit of advice, people, get used to them, because you're going to see a lot more of them in your A-levels. On we go. Big algebra. So, you know these are coming. You know there's going to be a lot of writing. You know it's like we've had already. Lots and lots of factorising. So, this first part, difference of 2 squares shows its face as always. So 2x minus 5. More factorising in the bottom, but also, like on other questions, they're all prime numbers. So there's only so many you can pick from. It's 5x plus 7, and it's x minus 1. And we're multiplying, and what we're going to do here, we're going to combine them so that they're all over x minus 3 and 2x minus 5. So that means to combine them, we would need to have multiplied the 2 by the 2x minus 5. So that will give me 4x minus 10. And I would need to have multiplied the -3 by x and by -3 to get +9. Good news is we don't have to write it all out again, because when we're timed in, this is just two really tricky looking fractions. Facts are, there's something on the top and something on the bottom which will cancel. Hopefully, more's going to happen, but it won't happen before we tidy it up. So, we've got 2x plus 5 on the numerator, 5x plus 7, and x minus 1. And over here, we've got x minus 3 on the bottom. On the top, if we simplify, I'll do that because you might be able to guess what's coming. We've got an x and a minus 1. That's how they simplify. And bosh bosh, they go. But here's the thing, nothing else cancels. Now, I want it in its simplest form. Don't expand those brackets. Who could make... Is that any simpler? I don't think so. Leave it alone. 2x plus 5. And we've got 5x plus 7 on the bottom and x minus 3 on the bottom. Like I said, don't expand the bottom. What's the point? Next. So number 23. A very, very, in my opinion, unfriendly vectors question. And it's always difficult because there isn't a diagram. So I drew a few rough diagrams first because you need to make... So I did them in pencil on my worked answer, did them on a bit of scrap paper actually, and rubbed them out. The best diagram, I think, to explain what the hell is going on is one that looks like this. Like that. Like so. Doesn't have to be accurate or anything. But then it tells us I'm going for O to A is A. That's that done. O to B is B. That's that done. C is the centre, is the midpoint of OA. Let's squeeze it in. Doesn't have to be tidy. D is on AB, such that A to D is 3 lots of. So that's 3, that's 1. So D is further down towards B. You could write 3 and 1 as 3/4 and 1/4. E is the point such that O to B is twice the distance of B to E. That's why I say I had to play around with a couple of diagrams first to make sure I think I've got a decent one. So first thing, I always make an observation. When you've got a triangle, always write down if there's a missing side. We've got O to A, we've got O to B, we haven't got A to B. Always worth making a note of it, because even if you hate vectors questions, just by stating the obvious again, you are grabbing 1 mark out of 5, even if you hate the topic. And if you hate the topic, 1 out of 5 is certainly not a disaster. So to get from A to B, I go towards O, which is minus A, and I go plus B. So there we go, I've got B minus A. I'll just have to get rid of that to give myself a bit of room. Here we go. To say a bit of room, I need a lot of room. So let's just keep the question in mind. Using a vector method, prove that C, D, E are on a straight line. That poses a question. What is C to D? Okay, that's the key for part 1 of this question. Part 2 of the question, if we do C to D, what about C to E? Because here's the thing, if they are on the same straight line, well, they already start at C. If they lie in a straight line, they will be a multiple of each other. one might be double or treble the other. So in other words, they should end up in the same form. So the same scale factor to A's and the same scale factor to B's would be another way of putting it. So let's see what happens. So to get from C to D, so that's there to there, I'm going to go via A. So I've got that line there, that's a half A, and I've got this line there, that's 3/4 of AB. Now I've already written AB down, I've just scrolled it off. Let's a half A. Now 3/4 of AB is 3/4 of that. So we did need it. It wasn't pointless. So 3/4 of B minus A. So let's simplify it. We've got a half A, take away 3/4 A, and we've got 3/4 B. Whoops, forgot the A. Now there's a quarter in each. It's going to be easier to compare if there isn't. So I'm going to take a quarter out, and I get negative A plus 3B. So what I'm hoping is that the answer, oh, that's a rubbish B, is the answer on the right looks something like that. Don't really care what's in front, as long as we get the same components. Let's go. So C to E, I'm going to go a different way. I'm going to go via O. So I'm going to go C to O first. That is minus a half A. I'm then going to go O to E. Now here's the deal. We were told that O to B is double B to E. So they're equal. So in other words, to go from O to E, it's 1B plus a half B. It's 3/2 of B. Now guess what happens when I take a half out? Negative A, 3B. Boom. But I do need a statement. And what I would write is something along the lines of C to D is, whoops, C to D, that's this bit. If I double it, because a quarter needs doubling to get a half, I get CE. In other words, they are a multiple of each other, and it's obvious in the notation they both start at C. So bosh, they are indeed hence. Always love to get the word hence in. Hence, they are a straight line. What a banger of a question that was. Let's go. So finally, a very strange looking completing the square, but let's crack on. I rearrange it and take the minus out. So a minus, change the signs of everything. So it's positive x squared, positive 4x, negative 7. And now you can focus on completing the square inside the square brackets. So now you can just crack on as normal. Halve the number next to x, square it and subtract it. And we're basically there, aren't we? Because the minus should have the brackets. Minus 11, and it wants it in that form. So it wants the number first, because minus times minus 11 is positive 11, and minus times those brackets, we have a minus in front of those brackets. There we go. Question B. do notice it's exactly the same thing. All right, that's the key. It's in exactly the same form. And because you've completed the square and it says use your answer to part A, your hands are tied. You must use the answer to part A. So I wrote in mine, so y equals, whoops, all the way around. So x equals y plus 3. That's the key. So if we are solving this, we are really solving this, and we are really therefore solving this. And when you're solving, you are putting it equal to naught. So let's just rearrange and get it as x equals. So leave the 11 where it is. Add the x plus 2 all squared to both sides. Square root both sides. And subtract 2 from both sides. Now notice in my voice, haven't finished yet. That's a terrible 11. How can you mess up a 1? Because don't forget, we don't want answers for x. X is really y plus 3. So to get your answer, you need to subtract another 3 from both sides. So you end up minus 2 minus 3 is minus 5 plus or minus the root of 11. Great looking question. And finally, just a random, nothing connected, write down the coordinates of A, the maximum point. So don't forget, it's not about what form it's in. Maximum point logic here is the same as minimum point logic. Your x value is the value which makes the bracket 0. There we go. And when the bracket is 0, what happens? Well, all that becomes 0. And you end up with y equals 3. So same logic as you've seen on much easier ones, just applied here to a much harder one. So there we go. What's that? 58 minutes or so. Must have been a pretty tough paper, that. Didn't like that Venn diagrams question, if I'm going to be honest. And a few tough ones at the end, but plenty of questions to pick up marks earlier on. So overall, a fair with some tricky questions. So good luck, and hopefully I'll see you on the next one.